All right, everybody, so this is going to be an impulse review from, the homework that you had last night. Again, these are all the equations that you really do need in order to solve this stuff, but let's get started with these true or false. So we needed to highlight the correct answer. If the net external force acting on a system is 0, then the total momentum of the system is 0. Again, if the forces acting on the system are 0, then the total momentum itself is going to be 0 or unchanged. That's true. 2, true or false, impulses are smaller when bouncing takes place. This is false. Impulses are greater when bouncing takes place because basically the thing comes to a stop and then bounces back up again, and the force required in order for something to bounce back up again is greater than for what it was to have it stop. Number 4, the padding on a dashboard lengthens the time of a passenger's impact during a collision. This is true. All right, so if we increase that impact time, then we are going to decrease the force that we feel on ourselves. That's why we have airbags, padded dashboard, seat belts, the crumple zone, all that good stuff. So multiple choice questions. Which has more momentum, a large truck moving at 30 miles per hour or a small truck moving at 30 miles per hour? So this is when you need to recognize that momentum is equal to your mass times velocity. So they're both going the same amount of velocity, but now it's like the rhino and the toddler, right? We have to recognize which one has more mass, and that is going to be the truck. The next one, compared to a sports car moving at 30 miles per hour, the same sports car moving at 60 miles per hour has, well, we have to recognize again that the masses are now the same, but the velocity is different. So the momentum for each is going to be different. By how much? Well, it's going to be twice as much momentum. So if you increase your velocity by 2, then your momentum is going to increase by 2. If the momentum of an object changes and its mass remains constant, either its velocity is changing, it's accelerating, there is no force acting on it, it would be all of the above. Or there is a force acting on it, I'm sorry, I must have read that wrong, but it is all of the above. Okay, so if our momentum is changing, then something is happening. It's increasing in speed, or it's accelerating, or there's more force acting on the object. A hockey player swings their hockey stick and strikes a puck according to Newton's third law of motion. Which of the following is a reaction to the stick pushing on the puck? Well, it must be that the puck is also pushing on the stick with the same amount of force in the opposite direction. Number 10, the diagram below shows a cart moving with a certain amount of velocity v on a frictionless surface as a wooden block is being dropped from above. The block then falls straight down onto the moving cart. So we see that this before and after. So this cart is moving with a certain amount of velocity, and then it adds more mass. And then after, we are asked what is going to happen to this velocity. So which of the following statements describes what will happen after the block lands on the moving cart? The answer here is C. The cart will move and continue to move to the right at a velocity, but it's going to be less than the original velocity of that cart. Why is it less? Well, because more mass is added to the cart. And these are the fun problems. These are the ones that contain math. So I brought out my whiteboard and we can take some time to actually go over this. So what is the average momentum of a 70-kilogram runner who covers 400 meters in 50 seconds? So the first thing that we want to do is recognize what we are given in the problem. So we are originally given a mass and a distance and a time. Okay, so the mass is equal to 70 kilograms. Distance, d, is equal to 400 meters. And we're given a time of 50 seconds. So this is one of those problems where you really need to think back and think about what we talked about previously. And we talked about linear motion. All right, and with linear motion, we said that velocity was equal to distance over time. Okay, so the distance over time, well, we're given a distance and we're given a time, which means that we can solve for velocity. Woo! Right? So we take this 400 meters and we divide it by the time that we were given, 50 seconds, and we should get 8 meters per second. So that is the velocity of this runner, 8 meters per second. So now we have to recognize, all right, what are we supposed to solve for in this problem? We just did a whole lot of stuff, but what do we have to solve for? Well, that would be the average momentum. Okay, so we're trying to solve for this average momentum. So we can say that P is equal to mv. Again, that's just the equation for momentum. So now we just have to plug in what we know, right? So this is 70 kilograms times 8 meters per second, and you should come out with the momentum of this runner. And you should find that the momentum of the runner is 560 kilogram meters per second. All right, let's look at the next question. So Tiger Woods hits a 0.050 kilogram golf ball, giving it a speed of 75 meters per second. What impulse does he impart to the ball? And I gave you a hint. I said, what does impulse equal to? Ft equals your change in momentum. Huh. All right. So let's look at what we're given in the problem and write it down. All right. So Tiger Woods is hitting a golf ball, and this golf ball has a certain amount of mass, and this mass is equal to 0.05 kilograms. And then we said speed. Now, speed to us can also be velocity. It's just when direction doesn't matter. So velocity is equal to 75 meters per second. And now we want to know what impulse does he impart to the ball. So what we need to solve for is this change in momentum. Okay. So in order to solve for the change in momentum, we need to solve for the change in velocity. And that's because P, or I should say the change in momentum is equal to mass times your change in velocity. And right now we just have velocity. We're not really sure what the change in velocity was. So our change in velocity is equal to velocity final minus velocity initial. Well, what was our original velocity? Well, it started from rest. So this initial velocity is going to be 0. So we can say that the change in velocity is equal to our final velocity. Woo! All right, it saved us from a whole lot of work. So all we have to do now is say that the change in momentum is equal to our mass times our final velocity. All right, so our mass was 0.05 kilograms. And we're multiplying it by 75 meters per second. So this change in momentum is equal to that two things, those mass and that velocity multiplied together. And you should get 3.75 kilogram meters per second. So let's move on to the next question. Oh, but that didn't really answer this question, right? So we found the change in momentum, but now we want to know the impulse, right? Impulse. So impulse is equal to our change in momentum. So impulse is also equal to this 3.75 kilogram meter per second, or you can say 3.75 Newton seconds. They're both the same units there. Okay, so next one, Wayne hits a stationary 0.12 kilogram hockey puck with a force that lasts for 1 × 10⁻²² seconds and makes the puck shoot across the ice with a speed of 20 meters per second, scoring a goal for the team. Yay, go Wayne! With what force did Wayne hit the puck? And I said, hint, change the time from scientific notation first. Okay, that's a pretty good hint. So let's move and see what we need to do for this one. Okay, so I'm going to start with this time. I'm given a time of 1 × 10⁻² seconds. And this is when we have to think back to scientific notation and what this is really telling us. So the important thing to notice here is that it's a -2 in our exponent. And we have to also recognize that it's a base 10, which is great. We love base 10 things because all we really have to do is say, all right, well, the decimal point is starting here. And because it's a negative number, all I have to do is move that decimal place over to the left twice in order to get this out of scientific notation. So I'll go ahead and do that. 1, 2. My new decimal place is here. And I just have to add a 0 into the spaces. So this time that we're really given is 0.01 seconds. And this first 0 isn't really necessary. It just always helps me to never miss this decimal. Okay, so this is the time that we are given. And we are also given the mass of 0.12 kilograms. Okay, so we're given a mass, we're given a time, we're also given a speed, and again, speed is the exact same as velocity, just, the direction is not important to us. So we can say this is 20 meters per second, and it's scoring a goal for the team, and we want to know how much force is being applied to the hockey puck in order to have it move and travel at this certain speed. Okay, so all we have to do is say that our change in momentum is equal to our impulse. All right, so this says that your mass times your change in velocity is equal to your force times time. So now we just have to plug in what we know, 0.12 kilograms. The change in velocity, so it started from 0 and it went to 20 meters per second. So we can say it's just that final velocity, and that's equal to our force times time. So force times 0.01 seconds. All right, so what do we need to do in order to solve for this force? We just got to divide out 0.01 seconds on either side. Okay, so that cancels out over here, and we're left with force is equal to 0.12 times 20 divided by 0.01 seconds. All right, and we should get a force of 240 newtons. All right, so that is the force that is being applied when Wayne hits the puck. Okay, so now number 13, a tennis ball traveling at 10 meters per second is returned by Venus Williams. It leaves her racket with a speed of 36 meters per second in the opposite direction from which it came. What is the change in momentum of the tennis ball if the 0.060 kilogram ball is in contact with the racket for 0.02 seconds? And what is the average force that Venus hits this ball? And we are told a hint to draw a picture with velocity vectors to show which is the positive and which is the negative. So let's start on this one. So I'm going to start with a picture. All right, so this is going to be Venus Williams, and she's playing tennis, so I'm going to give her a racket. All right, that's her tennis racket. So this ball is originally coming towards her with a certain amount of velocity. So I'll call this my negative side, and I'll call this my positive side. So in order to apply these velocity vectors here. So this was 10 meters per second, and then Venus Williams hits it, and it returns to the opposite side with 36 meters per second. So now I have to recognize, all right, in which direction does each happen? So this is actually going to be my negative, and this is going to be positive here. And I'm running out of time, so y'all check this out in the next video.